This is Jeremy. Tariq has done a fantastic job of putting together a great slide deck, and I would really encourage everybody to pull these down and look over them later. We do have a lot of slides, so I'm going to just buzz through a whole group of them here pretty quickly so that we can at least kind of see everything that's in the slide deck. I would, like I said, encourage you to come back and read them in a little bit more detail later. So the next little bit that what we're going to chat about was Oracle Clusterware, and Tariq has given a good introduction already. I hope that Syed will join us soon because he'll also have some good things to share. So Oracle Clusterware, the important thing I think to remember if you're new to Oracle RAC is that Oracle Clusterware is it's a whole different piece of software, really. It's a separate product. It's something that you install separately, but it is very tightly integrated with the cluster database. Clusterware is something that you can install without using RAC. It's an independent product. You can use it to make a single database into a failover database. So as you see on the slide here, it is the layer between the operating system and the database. Next slide. Now, the next two slides give the next few slides give a list of some of the different things. We'll just move through these pretty quickly. There's a couple of the services. Go ahead and go to the next slide, Tariq, as well. And the next one you're going to see cluster synchronization services, cluster ready services, event manager. These are some of the different components of Clusterware, and then keep going to the next slide, the physical components. The physical components, the OCR, and the voting disk, and we'll get into these in a little more depth a few slides later. Keep going to the architecture slide, Tariq, the next one. Very briefly, the Clusterware itself is a collection of different bits and pieces. Let's see, this slide is showing some of the different functions that it provides, and if you can move on to the next slide, what we're going to now show is the names of the different software bits that provide those functions. You can come back to these slides later and look at them more closely, and then go ahead and move on to the next slide after this, and we'll see sort of an example bird's eye view of a 3-node cluster. And you can see some of those processes talking to each other. You see at the top there's a little red dot that says VIP. We're going to come back to later to that. That's a very important little piece of information that you'll want to remember. Also at the bottom it says raw devices. That's a little outdated. Generally we do not use raw devices anymore. The shared storage, Tariq has already mentioned that Oracle cluster databases use shared storage. That's a very important point to remember as well. One of the toughest things as you're learning about Oracle cluster databases is going to be remembering which parts are shared and which parts are separate. So some parts of, for example, the data files or the table spaces, there's only one of those for the entire cluster. Other things like memory structures and processes, like your database writers, your redo logs, every single machine in the cluster needs to have its own copy. And the more that you are exposed to it, you'll start to recognize and remember which things there's one of it and which things there are many. Let's go to the next slide. It shows you a slightly more detailed picture, under the covers. And then the next slide after this is going to another detailed view of, and this is kind of nice because this shows you a couple of the different pieces of Oracle. You see Oracle Clusterware is in red. The next slide, go ahead, Tariq. The Oracle Clusterware here is in red. The Oracle database is in blue, but you can see that they're all tightly integrated together. And the next slide after this is, again, sort of similar. The next slide after this, have we moved on? Go ahead and move to the next slide. This guy here introduces you to something that we're going to talk about a little more later, which is at the bottom of this slide, you see 3 things that are shared: a global resource directory, global cache services, and global NQ services. Those are the new names. They've been renamed throughout the years with different versions of the database. Those are an important thing, and we'll talk about them a little bit more in some of the future slides. Let's let's move on to the next one. We're going to talk about the node startup. Now, all of the software on the server does act like a stack. So the clusterware, as I mentioned earlier, is between the operating system and the database. What that means is if the database wants to do something, it talks to the clusterware, and then the clusterware talks to the operating system. That's how the communication works. Because of that, they have to start up in a certain order because the clusterware needs to be running before you can start a database. Now, there's actually even more dependencies, and this picture shows you all, well, many of them. You see the operating system starts first, and then the clusterware. ASM we'll talk about a little more in depth later. That's the storage, automatic storage management, and that's an Oracle software for managing disks. Then the instance in red. If you are not very clear on terminology, it's very important to understand the difference between an instance and a database. And this is, if you've worked with other databases like SQL Server or MySQL or Sybase, the terminology can get very confusing because in MySQL, a database is very different than in Oracle, what we call a database. The database usually means the data, the set of files that are on the disk. When we want to talk about an instance, that means the set of processes and the memory structures, generally speaking. So what you don't run a database in Oracle, you run an instance. You start up an instance, you start running an instance. The database is sitting on the disk. The instance is what accesses the database and manipulates the database, queries the database, and it gives you data back. In RAC, you have multiple instances, more than one instance, but only one database. It's a very important thing to understand, and that'll just help you understand many other things. Everything else will make more sense if you understand that very well. There's one database, there's more than one instance. The listener starts up, the service, and the VIPs, and we'll keep going with that. Let's move on to the next slide. I'm probably taking too long on these slides. We're going to run out of time, I'm afraid. So looking at a couple of the daemons, the processes, these are just, by daemons, that means a process that runs in the background automatically. These are a few of them. Let's move on to the next slide. Oracle Clusterware Framework. The clusterware, that's right. Just as, to throw this out there, this is a little bit more of an advanced topic, but we definitely want to tell you about all the features that are there. The clusterware is very customizable. Not only can you start and stop, you can write your own programs that use the clusterware in some of the same ways that the database uses the clusterware. And I've actually worked with customers where they have in fact done this, and they've used the clusterware framework to make their own applications highly available, in some cases make other applications, give failover capabilities to other applications. Let's move to the next slide. And cache fusion. All right, so now we're moving on to the next topic, which the next topic that we want to do is look a little bit more in depth at this idea of cache fusion. It's a buzzword that you might have heard before. This is something that was a major new feature when Oracle introduced it. Their marketing department made lots of noise because they did a lot of work to make this, and they did a good job with it. It works quite well. In Oracle 8, Tariq mentioned that the product was first called Oracle Parallel Server, and if some data was on one of the machines in the cluster and somebody on a different machine needed it, it would cause something that we called a block ping, meaning that the first machine had to write it to the disk, and then the second machine would read it off the disk, and that was called a ping. And this was something that was a big headache for a lot of database administrators, and Oracle spent a lot of time. There's a lot of reasons that it needed to work that way because it was very complicated to do things in other ways, and that was the best way to start. Starting around, I believe, the Oracle 9, I think, time frame. Correct me if I'm wrong, Bert or Tariq. I think it was around Oracle 9 they introduced this idea of cache fusion, and essentially what they did is that instead of writing the blocks to disk and reading them back, they would just transfer the block over a network connection from the first machine to the second machine.
That is correct, Jeremy.
Yeah.
It was with version 9i.
Yep, with 9i. Okay, thanks, Tariq. Yeah, so the third bullet point there makes an important point. We don't mirror the blocks across the cluster. They synchronize, meaning if the block is on one node, we're not going to copy it anywhere else unless we need it somewhere else. This is also the reason the interconnect is the name that means the network connection between the nodes in the cluster, between the servers that you've taken and made into a single cluster. It's very, very critical that the interconnect works well and that it's fast enough. This is especially because of cache fusion, because of this feature. Let's move to the next slide. This is just a few dynamic performance views. Move to the next slide, please. These are the three things that I mentioned earlier. Now we're coming back to them. The global cache service, the NQ service, and the resource directory. The cache service is the process that runs in the background which actually copies those blocks. This is the processes that open the network connections. The NQ service is what handles locking. Now as soon as we let there be multiple copies of something, Oracle has to manage it and be very careful that they don't get out of sync, that you don't get old copies, you read data from old copies and return that to the application. So these processes are what are going to keep track of the data. Let's move to the next slide. The global cache service waits. This means you'll hear a lot about wait events. Today, the way that tuning on Oracle databases is widely done is by thinking about time and the amount of time that we spend doing things. And because we're thinking about time, therefore we care a lot about when we wait for things. So this is a way you'll see wait events about global cache services. These are where you're going to see if your interconnect is too slow. You'll see events like this. Next slide. This is a quick diagram. If you are a visual person, maybe this will help you to sort of see it in a picture. In fact, go ahead and go to the next slide, because I think the next one is actually just the same slide again, but slightly easier to see. Right. Yep. This is just showing you the buffer cache is the copies of data that are in memory in the server, and this is showing you some of the processes that move back and forth. Let's move to the next slide and talk about the OCR, the cluster registry. This is our next topic. We've moved on from cache fusion. If you have any questions, just take note of them and we'll come back to them toward the end. Looking at the OCR, the easiest way to explain this is you think of it like your Windows registry in a way. In fact, it's structured very similar. It is almost a little tiny database in itself, but it's only sort of critical information that's needed in order to start the clusterware, which has to be running before we can start the database. It has information like the names of the databases that exist, or the names of the servers that are in the cluster, just basic information to sort of communicate across the cluster. If you're using ASM, which is really a good way to go, then the OCR is automatically mirrored for you. So that third bullet point says you should, that says OCR and voting disks. Those are two different things. It says they should be mirrored. They will be automatically if you use ASM. And I should point out, if you use ASM and, with 11.2, and you have a couple disks to mirror, then it will. Let's move on to the next slide and keep moving.